Hello and welcome to another section in further mathematics. In this section, we'll be looking at the topic integration by parts. Integration by parts. Now, before we proceed into what we have for today, I'd like us to take a very quick review of our previous lesson. Okay, welcome back. Now, when we talk about integration by parts, it's just synonymous to the product rule when you talk about integration. For example, if you're asked to integrate two constants like 2x sine 4x, you know, normally in integration we do that of the product rule. We square this way and make use of the rule that says v du dx plus u dv dx. Now, if it were to be differentiation, would have applied this. If you're told to differentiate, if you have something like this and say differentiate it. But when it comes to integration, we apply a rule called integration by parts. Now we do the integral separately. That is why it is being called integration by parts. You separate it, perform the integral, then before you come back into getting your answer. And when it comes to integration by part, there is a special rule that goes this way. V du is equals u v minus the integral of u dv. That is how it is being done. Wait, let me say this is 2. If you have a question of this nature, now this is a general rule for integration by parts. One of the functions you're trying to differentiate will assume the value of v, while the other one will take the value of du. Then you get, using v and du, you evaluate the value of u, you evaluate the value of dv, put it into this equation, and you get your answer. Now we have a question here on the board. Can we just use it in explaining the terms? Now, we stated earlier, let's call it our example 1. Our example. So integrate. We are meant to integrate 2x sine 2x. We are given this to integrate. Now, one of the first things I want us to take into consideration is adequate usage of terms. Now, with this, let's make our v to be equal, because we need to get u, v, u and dv. With that, we are done with the integration. Say our v, let's take v to be 2x. Let's take this point to be 2x. Our v. Let's say our du is equal to sine 2x. Our du is equal to sine 2x. Now, another thing we have to look for is, since we have v, let's look for the value of dv. Now you know that dv is equal to 2 dx. From here, dv is 2 dx, and the value of our u, since we have du to be this, then the value of our u, we have to integrate it. So if you integrate sine 2x, you have minus cos x. So we now have, from here we have our u, we have our v, we have u, we have v, we have u, that is this, we have dv, that is 2 dx. Now we substitute it into our equation. Now remember, we're told to integrate 2x sine 2x. This is equal uv minus the integral of u dv. This is a rule that was given to us. And remember, let's start substituting it. We now have our value of u is what? Minus cos x. Our value of v is what? V is 2x minus the integral, our u is what? Our u here is minus cos x. Then our dv is 2 dx. So this times this, we have 2x, that is minus 2x cos x, minus, okay, it becomes plus because minus times minus is plus. Now we now have 2 outside it, integral of cos x dx. Now we still continue with what we have in front of us. We now have minus 2x cos x plus 2. The integral of cos x is sin x. Sin x plus c. So our final answer becomes minus 2x cos x plus 2 sin x plus c. So the integral of 2x sin 2x is equal to this, and this type of integration is properly classified as integration by parts. Now what if you now have a partial fraction to integrate? A partial fraction was being given to us. Partial fraction was presented to us to integrate. Now the first thing that will come into our mind is, let's say example, let's integrate. You know what a partial fraction is? Now let's say, for example, we have been told to integrate 2x plus 3 over 2x plus 1 x minus 1. Now if you are told to get the integral, you know naturally in partial fraction there's something called sign of equivalence. So you now say it's equivalent to a over 2x plus 1 plus b over x minus 1. That is a sign of equivalence in partial fraction. Now let's solve it. Let's expand the brackets. You now have 2x plus 3 to be equivalent to a x minus 1 plus b 2x plus 1. Now at this point we want to get the value of a and value of b. We now say let x equals 1, and if x equals to 1, we now have 2 times 1 plus 3 to be equivalent. If this is 1, we have 1 here. 1 minus 1 is 0, so automatically our value for a becomes 0. We now have our b to be 2 times 1, 2 plus 1, 3. So we now have 3b. So therefore the value of our b is equal 5 over 3. Now we now say let want to get the value of our a. Now we can now say let x be equal to minus 1 over 2. We are using this x equals to 1 so that a number that if you can add here, one of them will be eliminated. Now if you use x as minus 1 over 2 into this equation, this becomes 0, this becomes minus 1, and minus 1 plus 1 is 0, so we are eliminating b now. So it becomes 2 in bracket minus 1 over 2 plus 3 is equivalent to a in bracket minus 1 over 2 minus 1. So you discover that with this the value of our a is equal to minus 4 over 3. Now you've gotten this. Let's express our equation. Remember the original equation was we started with 2x plus 3 over 2x plus 1 x minus 1. So we now have the value of our a is minus 4 over 3. Then there is 2x plus 1. Then we now have plus b is 5 over 3. Then we now have x minus 1. You saw what we just did. After solving for a and b, we came back to our master equation to put our a as minus 4 over 3. Then remember this 2x plus 1 is under here. Then plus this. So this is what we are interested in now. These two. But remember that if you integrate 1 over x, it will give you ln x. So this is equivalent to okay, minus 4 over this 3. But now these are 2x, you have to differentiate it. If you find the integral of 2x, you have to. So 2 times 3 is 2 times 3 is 6. So with this, you now have minus 4 over 6 ln 2x plus 1 plus 5 over 3 ln x minus 1. So this is equal to minus 2 over 3 ln 2x plus 1, then 5 over 3 ln x minus 1. So if you have to find the integral of this fraction, partial fraction, this is exactly where you will arrive at minus 2 over 3 ln 2x plus 1 plus 5 over 3 ln x minus 1. You can see that the concept is very, very straight and forward. There's no stress in this. Now I want you to test your strength of understanding on the concept of partial fraction, integration of partial fraction. So by so doing, be ready to take the test that will be coming up shortly on your screen, and make sure to also refresh your memory on a constant basis using this material as a point of reference when it comes to partial fraction, integration of partial fractions. Thank you and see you in our next lesson.